Okay guys, like always there's a lot going on in the workshop. We took the Ultima to the Dyno this morning and that went great, and very exciting that Dawies' new engine arrived for the Nova. Yeah, so I just came back from the Dyno. Yeah, the throttle response was a big problem. It's got ITBs on it, and to be honest, they're probably a little bit old, and so we really struggled to find the balance. Also, the way the whole thing is assembled is the TPS is really far away from the input shaft, so there's a lot of movement. It has to move all the throttle bodies before the TPS, but we managed to tune the vacuum control back into it. So on average, it's a hell of a lot better. Is it perfect? No, but a lot better than it was. And also the throttle response is so much better. So it actually sounds incredible when you do like a throttle blip now. Yeah, but it's far from a perfect car yet. I think it needs a lot of work to make it more livable. But for now, we're done with it. It needs to go home. We've got more racing cars to fix. This is Dawies' new engine for the Nova. It's a Gen 4 Coyote engine. The camshafts are slightly different between the two engines, slightly more lift, duration. The oil pump has changed, the conrods are different. But the big thing is the engine can rev a lot higher. That's most of the work that went into the Gen 4 engine, is that it can rev higher. I've seen some videos on the internet where people are revving them to 9,000 RPM. Not that it's really making power up there anymore, but with the turbojet intake manifold, big throttle body, makes maximum power all the way up to 8,000. And it seems that they are reliable at 8.5. That's what they are saying to us. So if we can rev it all, live at sort of 8,000, that will make the car a lot faster, just because we can stay in lower gears for longer. Like I said earlier, the cars have different oil pumps. That's actually our biggest struggle, is the dry sump isn't just bolting straight on. Tomorrow morning somebody is actually coming to 3D scan the bottom of the engine so that we can get it into CAD and help Marco design what he needs to make the pickup work. Otherwise, it's just dressing some of the stuff over, the fuel rails, the high pressure fuel pump and that sort of stuff over from the one to the other. And yeah, that's really it. It's just putting it all back together. And obviously this kind of engine and that car, once it's in, it's very hard to work on it. So it's important to do everything correctly the first time around. Okay, so this is a dry sump for the engine. It's a beautifully made piece of equipment. It's obviously made out of a billet. So the standard engine, the oil pump will meet up with this fitting, and it's quite a straightforward, just bolts on. It sucks the oil out of the tank. But the new engine, this actually sits at an angle. So yeah, this is why we're having this area 3D scanned, and the same with the engine. And we're going to try and see what sort of gooseneck we can make here to connect the oil pump with the dry sump. Obviously, to recreate this whole thing is just not worth it. So yeah, that's probably the biggest challenge. One of the other things we had to do was to relocate some of these studs, as the Gen 4 engine and the Gen 3 engine clearly uses an only left-hand branch. It's slightly different. Maybe it is to stop the interchangeability, but whatever. So we had the gut here to line up where we need to line up the drilling of the holes and tapping. We got some professionals out here just to make sure we're not putting it in skew. So yeah, these guys came out sorting it out. Something else we've got going on, we've got Dexter's E36 turbo beam here. I would like to say this is still a relatively new build. It's been turbocharged for a while, but what I mean is it stood for a long time, and never was really a successful build. And as he's trying to use it now more, we built him an engine, and now he's obviously running it a bit more, Paul's tuning it. The other shortcomings are coming out, so that's sort of what I mean. And I often see people trying to use, obviously for good reason, the cheapest parts they can find, or the only parts they think they can find. And those parts then have shortcomings. So on this car, we're currently fitting a TIAL water-cooled wastegate, which is what we prefer to use. I like the story behind TIAL, I like the brand. And also, I think the quality is absolutely top-notch. So it's a water-cooled unit, which also considering in the environment it lives on the exhaust pipe, and the amount of energy that goes through it, and the consistency that we expect as a racing driver to feel under your foot. The wastegate is such a big part of turbo cars, and the reliability and the spool up and all that stuff. So yeah, Caleb's busy welding the stuff in, and I can show you guys what it looks like. For, again, budget reasons and space reasons, they've modified the standard 3 to 8 branches into the exhaust manifold, which I guess works, but isn't definitely not the most elegant solution. On top of that, they've put the wastegate on the turbo. Now again, I don't want to get into a big argument. There are people that believe it's fine and dandy to do that. We don't particularly believe that. Plus, the air has to do a very acute angle out. You know, it's almost like they think air doesn't have mass to it. But anyway, that's fine. So yeah, Caleb's busy fitting this beautiful wastegate. Obviously, it's slightly bigger. Obviously, vacuum and water lines. And once it's in, it's going to be very consistent and work properly. The biggest thing with wastegates that people don't realize is the different materials that it's made out of. A cheap wastegate is made out of, you know, cheaper materials, and when it works at this extreme heat, you know, the little valve seat will somehow weld itself to the seat and stay closed, and the spring will go soft, so it won't be the same as when it's cold, and a multitude of other stuff can go wrong. So yeah, a wastegate in a complete build is a relatively cheap thing. Just buy a nice one from the start, if you can afford it. The turbo he's got on here is a GT35. It's still a Mr. Turbo. You know, it really is pretty much the cheapest thing you can buy. They offer great performance for the money. Ultimately, I think Dexter will move on to a ball bearing turbo, and for similar reasons why you will move on from the wastegate you used to use to a more, you know, well-known waste. You know, the turbo response is so much better, the longevity is there, but yeah, it's expensive to buy, and it really is a big jump going from something like that to a sort of. So we use the Pulsar turbos. They seem to be great value for money. They seem to be very accurate copies of mainstream turbos, which are well documented. But yeah, we run it on almost all our big turbo builds have Pulsar turbos, and they work great. They're ball bearing turbos, they're water cooled, and the response and the longevity is incredible. While all that's happening at the workshop, we are here at James's place to come and see how the E36 is doing that we're making light. The guys are busy fitting the rear door skins. You know, we obviously wanted to make it look beautiful when it's done. So these pop rivets are in now, but they will come out. They're just doing some fiberglassing for brackets in the inside. Then the glass fiber doors have been fitted. They're just sanding them down. The locks and all that stuff has been fitted. And then we've had a plastic window made. It isn't glued in right now, but it will be obviously shortly. And then when it's all done and said and done, we'll spray the inside of the car where we cut all the bits and pieces out. Okay guys, thanks for watching. We'll keep you guys updated, and watch for next time.